Hello, I'm Mrs. O'Brien, and this video is about homework questions 4 and 9 on section 12.4. The first question is asking us to basically derive the formula for the area of a trapezoid in 4 different ways. The first is to show how to combine 2 copies of the trapezoid to make a parallelogram, then use the formula for the area of a parallelogram to deduce the formula for the area of a trapezoid. Let's look at this one. I have downloaded one of the GeoGebra applets to demonstrate for you. Let me load it. There we go. So I'm going to copy this and rotate it so you can see that I now have A and B, and then my height has not changed. So A plus B is the base and the height of this parallelogram. The reason why there's a 1/2 in front is because the original figure was only half of this. So that's why it's 1/2 times the area of the parallelogram. Again, and for this guy, it's A plus B times H. And that's what you're seeing right here. The next one is part B, and it's asking us to show how to cut off portions of the top of the trapezoid and combine these portions with the bottom part of the trapezoid as to make one or several parallelograms. So one way we can do this is by figuring out where the midpoint of the height is, and then we're going to cut it right here and move those pieces. Maybe. Let me reload it. There we go. There's half the height. There's the other half of the height. Cut it over, and then I can move these pieces, and there's 2 ways I can move them. One way is by cutting and flipping that part over, and I get one parallelogram, which is base 1 plus base 2 multiplied by my height divided by 2, and that's what you see right here. And there is another way I could have split that if I just take that back just a wee bit. See if it lets me. Right there. So there's another way when I cut it like that I could have put it together to also create a parallelogram, and it would look like this. So if I cut it the way we looked before, and then I move piece A here and B and C here, I would get again a parallelogram that has a base, this is actually a rectangle, of A plus B times 1/2 H. So it still gives you the exact same formula, but it doesn't do it with a parallelogram. It actually makes it into a rectangle, which is a special type of parallelogram. So both of those would be acceptable for question B. In this problem, letter C, we're going to subdivide the trapezoid into these triangles. You will notice that the purple triangle has a base of A and a height of H. There's the same height here. We drop the altitude right there. And the pink triangle has a base of B and a height of H. So basically have 2 triangles here, the purple one, which its area would be 1/2 AH, and the pink one whose area would be 1/2 BH. Those combined together would be the area of the trapezoid. I can show, let me load this page. Doesn't seem to want to load. There we go. So the total area here would be 1/2 AH plus 1/2 BH, or 1/2 H times A plus B for the area of the trapezoid. In our next example, they were asked for, besides the methods given in A, B, and C for this problem, are there still other methods? And yes, there are. So let me show you one. So one way is we could subdivide this figure similar to the way I have, and again you can adjust this so it looks, like a different trapezoid if you want. Doesn't have to be the trapezoid that I had originally. Any of them would work, but basically you're going to slide that part over, and you'll notice now that you have one large triangle that has a base of B1 plus B2 and has a height of H. So that is one additional way you could solve the problem. On this next example, we're being asked to determine the area of the shaded shapes and explain our reasoning. So they have this nice dot grid paper here for us, and they tell us that from dot to dot horizontally is 1 unit. That also means dot to dot vertically is 1 unit, but not diagonally. So only horizontally or vertically is it 1 unit. So when I look at this first figure here, if we'll concentrate on that, I kind of see it as though it could be cut into these 4 triangles with a square in the middle. So let me show you what it looks like. So for something like this, each of these 4 triangles around the outside and then this square in the middle. So if I find the area of one of these triangles, they're actually all the same. And so then I could just multiply by 4 if I wanted to. So let's look at this triangle 1, if we will. This is the base B, which is a length of 2. Here to here is 1, and here to here is 1 more. So that's a length of 2. Now remember, we go to the vertice that is opposite the base and drop the altitude down to the perpendicular from that point is our height, and that height is also 2. So that has a base of 2 and a height of 2, and it's a triangle. So if I put it in our formula, 1/2 base times height, I get 1/2 times 2 times 2, which gives me 2 square units. So this one triangle has an area of 2 square units. If you notice here, this has a base of 2 and a height of 2. This one has a base of 2 and a height of 2. And this one has a base of 2 and a height of 2. So since they all have a base of 2 and height of 2, they're all going to have an area of 2 square units. So I can just say 4 times 2 square units means the area of all of those triangles together is 8 square units. Then I find the area of the square in the middle, which is 4 square units. We could actually just count them, or you could calculate it by being a 2 by 2 square. This gives us a total area of 12 square units for this star-shaped figure. To me, this figure kind of looks like a spider, so I'm going to split it like where these leg-looking things are, and then along the body area here. The same thing over here. So now I see a couple triangles. So I see this triangle and this triangle, which look the same, and this one and this one. And then I have 2 parallelograms and 2 squares. So if I found the area of each of these parts, then I could add up all those areas together, and it would give me the total area of the shaded region if I find the area of the smaller pieces. So I'm going to label each of these pieces that have a duplicate. So I'm calling this triangle 1, triangle 2, or sorry, parallelogram 2, square 3, and then triangle 4. And I didn't label these yet because they're all congruent to the ones already labeled. So if we go ahead and find the area of triangle 1, we notice here it has a base of 1. If I follow the base over and go up to the vertex that's not on the base, it has a height of 2. So a base of 1 and a height of 2 are going to give us an area of 1 square unit. Then we have this parallelogram, and it has a base of 1 and a height of 1, so it also has an area of 1 square unit. And then 3 is just a 1 by 1 square, so that one's easy to do. And then 4, again we have the base of 1. If I follow it over and up to the vertex not on the base, I'll notice that I have a height here of 1 as well. So 1/2 times 1 times 1 gives me 1/2 square unit for triangle 4. If I added those 4 things together, area 1, 2, 3, and 4, I would end up with 3.5 square units for that part of it. Since these other parts that I didn't have labeled are duplicates of the ones to the left, I can just double this area. And if I double the area, I get 2 times 3.5 gives me 7 square units, because those purple numbers and the pink numbers correspond to their congruent areas. So that would mean my total shaded area for my spider-looking creature is 7 square units. Thanks for watching. Today's images and questions came from our textbook, Mathematics for Elementary Teachers with Activities.